with it. But for those who do not have maybe access to such, I would say at least buy one physical equipment, or you don't have to buy it. You just need to know someone who has it. That's my own advice. Know someone who has it, and then maybe the person gives you like a Telnet port or SSH port to that equipment, so you can just try to use it. Because many of the simulations, let's take them. Packet tracer, you can't run all the commands that you need to run on packet tracer. You can do a lot, but not all. GNS3 has limitations in layer 2. So some of the commands you have to run to configure layer 2, like maybe port fast, things like VLAN. In GNS3, you have to run the command in a different way, and that's not how actually you run it on a Cisco switch. So you need to remember that. For that, I have to always cram it and remember that, okay, in GNS3 this is how I do it, but in the actual Cisco switch, I have to do it differently. Yeah. So those are the limitations there. That's what I think.
Yeah. Okay, I'll tell you. I mean, my own thoughts about it. One of my own thoughts about it is I'll tell you, like, studying nowadays or in our modern times, one of the issue with studying is there's too many options, there's too many information, too many pulls in many directions, and it depends on your method of studying. But I'll tell you, my own method of studying is I have to have a structure. Otherwise, I get confused. Because otherwise, you have people telling you, read this book, no, it's this lab, no, it's this one, no, it's this one. Whichever one you're using, my advice would be make it simple and keep it structured. If you're using CBT Nugget, okay, CBT Nugget, I'll be dealing with 2 videos a week. Maybe I'll watch the video on spanning tree this week. So that's all I'm doing this week. I'm watching the video on spanning tree. I'll go on YouTube and watch videos on spanning tree. I'll search the internet and research on spanning tree. Then next week I'm doing OSPF. Then I watch my CBT Nugget on OSPF. Um, watch videos on YouTube on OSPF. Read textbooks on OSPF. Read the internet on OSPF. The next week I'm doing, so I have to have the structure. Otherwise, there's like too many pools. With this pool to do it this way or this pool to do it that way. So just pick a method that works for you, or just stick to it and be structured with it. So that's what I would advise. Otherwise, it can get like really, really crazy really quickly. Because as you're studying for spanning tree, you're like, should I go for EIGRP as well? Or should I go for this one as well? So just be structured. If you're doing spanning tree this week, focus on spanning tree this week. Yeah. If you're doing EIGRP next week, focus on EIGRP next week. If you're doing OSPF the next 2 weeks, make sure you just focus on OSPF for the next 2 weeks. So that way, it depends on your method of studying, but that works best for me if I have a structure that I'm following.
Yeah, I could say the structure I used with CBT Nuggets was get through a certain segment. The material is probably a much bigger, but I like getting everything broadly and not trying to try to understand it fully.
Yep.
And then I want to participate in active discussions to kind of help me get hands-on with it. That's why I got the actual equipment. And then I was hoping that I can break it down, like you said, which areas I need to focus on more that I don't grasp right away. And just maybe focus a day or two on those at a time.
Yeah. So that's just for like my own thoughts on it. So like one of the things that we'll try to do in this Hangout, at least for this search, one of the things that we try to do is to keep it as interactive as possible. Hello, Mark. How you doing? It's been a long time.
Yeah, it's been a while. Sorry.
How's your CCNA studies going?
Man, it's kicking my butt.
Why is it? For those that don't know, Mark started a CCNA classroom. I think it's the Cisco Net Academy, right?
Actually, I'm doing both. I got a grant to go to this boot camp for 2 weeks, and then I'm also going to the college so I can do it at a slower pace. And I went through the first half of the boot camp this week, and it was just overwhelming. I mean, it was awesome. It was so much fun, but it was just too much stuff too fast.
Yeah, I'm sure Maiwa and others can tell you like their own stories of boot camps. So tell you the first training of CCNA I went for. Yeah, carry on, Maiwa.
You went to a boot camp. Look, The only people who should go to boot camp are those who have either been working with a product for a long time, are so good at it, but just need a quick revision, or those who have actually mastered it and are ready to take the exam, but just want to do a quick. Boot camp is for a revision. It's too overwhelming when you do it. Oh my goodness! You went to a boot camp. Wow.
I know that was the first training I did actually, because I was in uni then. So I was in uni. So my dad sent me this money. I'm like, yeah, I'm not gonna waste this money. I'm gonna do something useful with it. So I'm like, yeah, there's this guy doing Cisco training in London. So I'm like, yeah, I'll go from Portsmouth to London. I'll go for this training, and it's gonna be for a whole week, Monday to Sunday. So I'm like, I'm dedicating. Hello, Namibia, how you doing? Sorry, Pamela, how you doing? So I'm like, I'm gonna dedicate the whole week, study CCNA. So I went to the class, and it was okay at the beginning, when the guy was talking basics. Then from day two, I basically just blanked out. I had absolutely no idea what the guy was talking about. It was like, so when you get to EIJLP, all you have to do is make sure that your administrative distance. I'm like, huh? Huh? Admin what? And before you ask the question, admin what, the guy's already throwing like about 10 more terms at you, and you're like, okay. I'm like, the only thing I can do is just give me the lab book. I'll just be typing exactly what I see in the lab book. I have no clue what I'm typing. I'll just keep typing it and all that. So yeah, boot camp is like yeah. Okay, nice to have you guys on. So just to let us know, like the method or what we usually do with these hangouts is we try to make it interactive. So it's not CBT not get, it's not training. It's all of us discussing together, learning from one another, asking questions from one another. And one of the things that we try to do is whenever we say anything, we try to explain it to one another so that we don't confuse one another. Because in IT, it's easy to confuse each other because we can just come and throw terms like you said, administrative distance, throw all kinds of different terms and people are confused. you know. So it's okay to do that when we're dealing with customers, You want to confuse a customer, just throw out a lot of terms that they have no clue about. But when we're within our own groups, so we try to explain it to one another and try to make it clearer. So what I'll do is I'll share my screen, and today we're going to be starting from the very basics. So we're not going to be doing anything advanced today. It's 1.5 hours discussion, 1.5 hours lab. So if you get your lab equipment, GNS3 packet trays already, so let me do a screen share here. Screen share.
I'm a packet tracer expert after this week.
That's nice.
I can break it just as good as anybody else.
I'm not sure if that's a good thing, but
I don't know if it's good or
yeah. Okay. Okay, so what we'll do is we'll start from the very beginning of like networking, and then work our way just to switching basics today. So at the very beginning of networking, what type of networking did we have? Not at the very, very beginning, but like when networking was becoming more popular, what type of networking, um, or what's like the history behind it? What type of networking did we have then? Anyone? So at the very beginning, what type of networking did we have then?
What did they used to have? You
mean like hubs?
Yeah, that's a good one. Hubs, yeah, hubs. So let's put that down. Hubs. So so the whole evolution. So hubs. So after hubs, what did we have?
Bridget?
I think before hubs we had stuff like vampire taps and stuff like that.
Nice one. Yeah.
I think something like that. Coaxial stuff like that.
Vampire taps. Nice one. So you know how not to confuse one another again, because I can see people looking. Whoa, vampire taps. What are we doing? Okay. So what am I? Yeah, carry on. Sorry, carry on, Taye.
Okay, I just have a question. What is vampire tax?
Yeah,
Never heard of
exactly.
this term.
Good one, Maiwa. You want to help us with that? So now you've confused us. Vampire taps. We have no idea what vampire taps are. Can you please explain to us what vampire taps are?
from what I know, and you guys could actually Google it and look for images.
Yeah.
If
Yeah,
it's
I
a
will.
vampire tap networking,
Yeah, let
and
me
then
know.
just click on images, you'll see it.
Yeah.
What happened before was it's almost the same way you have cable for those who have cable services, whereby you have a large coaxial. What the cable company does is that they'll run a big coaxial cable,
Yep.
and then they'll terminate with your let's say almost like electricity. You
Yep.
have a transmission cable going across,
Mhm.
and then you now have all the houses terminating or joining at a certain point to that transmission or distribution cable.
Yep.
So
Nice
that's
one.
really what it is.
Nice one.
So it's something like a soldered stuff together, and it's very difficult to to one is if it breaks, if it breaks, you break everybody. As in, you know how when you lose power, when someone loses power at certain points, that everybody on the street lose power, or if there's a problem with the transformer, everybody from that transformer downwards lose power.
Yeah.
So
Yeah. So
something like that.
yeah, so that's a nice one. So actually, just to break it down a bit more, what Maya is referring to is that it's actually called a logical. It's just well, it's not a logical bus. It's a bus network. So we used to have like
Okay.
this old bus network where all we had was, well, I'm saying we, I wasn't around in those days. But what we had was we had just this long cable on the network. So that's the network, it's a cable. So along this cable, you have other cables that are coming off of this cable. And at the end, you have these things that they call, what Maya called, vampire taps, where people can connect their computers to. So it's just a long simple cable. So like if we bring up the Google image again, um, what we actually had was we have something. Let's see, bus network. Okay, it actually, let's say 10 base. mm, let's say 10 base.
I put a picture there in chat.
Yeah, thanks very much. Let's bring that up. Yeah, exactly. So this is a really good one. So you just have just this long one cable. You have at the end, you have these terminators there called vampire tabs where you connect your computers to. And this is what they look like. They look like something like this. So this is what they look like exactly. This one. So you have this long cable. You have this thing hanging off of it, and then you plug your computer right here. And that was what we had as network in those days. Now, what's the disadvantage of this type of network? What's the problem with this? Pameni, what do you think? What's the problem with this type of network? I mean, it looks good. Pameni, can you talk? Or your mic is not working?
Probably, I think.
Hi guys.
Yeah, I can hear you now. Nice one.
Sorry, I'm maneuvering between two offices, trying to set up my wireless. Okay. To trigger any confusion on this
Your voice is really, really
bus
low.
network, once it breaks,
Your voice is really low. Not sure why.
uh, can you hear me now?
Yeah, it's better now.
Okay. What I'm trying to say is the problem with the hub is if there's a break in the middle, the network is separated in two.
If there's a break in the middle, yep, you said it causes
Yes.
network separation.
Yes.
What
Meaning, uh, from the side of which the network is being received to, if the hub is broken in the middle,
Yeah.
it gets separated in such a way that if, for instance, on your right side, these guys will no longer be connected to the network
Yeah.
as the caused by a break, let's say a cable break or threads.
Yeah, that's a nice one. That's a really nice one. So what Pameni is saying is that you have this network now. If something were to happen and there were to be a disconnection here, you're gonna have basically the network is gonna, the guys here won't be able to communicate with the guys over here. But yeah, typically speaking, that can happen even in a modern day network. If you have two networks and the router in the middle breaks, and the guys on the other side can't communicate with the guys on the other side anymore. Yeah, but what other issue can you see with a network like this? What do you think, Carlos? What do you think? What other issue do you think can
I
exist?
think it has to traverse the whole network basically.
What do you mean by
It has
that?
to communicate everything in a
Explain.
line. So if a machine on the end sends a signal, it has to go through each one.
Good one. So what if I get you very well, what you're saying is that if this guy over here sends a communication, it goes to everyone on the network.
Yes.
Yeah, good one. So basically, and that's like a big problem right there. If this guy wants to send something, if he sends it there, everyone on this network are listening to that communication. So that's the problem right there. So all
It won't scale very well.
yeah, exactly. Nice one. Listen to become
So instead of going through like a switch or something, it's all going to hit all those machines first
exactly.
until it finds
Everybody.
the right
Yeah.
Well,
MAC address.
Carry on,
not
Carlos.
to jump ahead, but like you'll get an initial broadcast even on a switch, but any
Yeah,
switch will kind of store enough layer two MAC address to know where to send the packets afterwards.
Yeah.
yeah, but this way everything gets everything all the time, right? Because it's
Right.
Yeah.
so.
It does all the time. So what other problems do you think exist with this type of network?
This network was not efficient enough
Yeah,
because
why? Why is it not efficient? What's the
because
problem?
at that time the cable length was around 100 meters. You
Yeah,
cannot connect you cannot connect more than 4 to 5 computers on the network because it will create unnecessary load on the network.
yeah,
Because every machine on the network will try to broadcast with every machine on the network will try to communicate one by one. Okay, this will lead to collision on the network,
yeah,
and this will drastically reduce the efficiency of the network because
yeah,
anything which is built, it has to be efficient enough.
yeah. Yeah, yeah, I think that ties in with what Carlos was saying about it doesn't scale very well. Um,
Yeah, it
yeah,
doesn't
what
scale
other
very well.
issue? There's another thing that there's a problem here that's not been mentioned yet. And welcome, Remilos. What do you think? Okay, Marawa, what do you think? What other issue? There's another issue that's not been mentioned yet with this type of network.
It's inflexible. You can't just okay, let's say we want to move we make this network in a house. Think about it, in a house.
Yeah.
And for some reason we have to move,
Hmm. Nice one.
we're in trouble.
Yeah.
Because
Yeah.
then it means that you can't move unless you go to your new location. You have to do this whole thing up all over again. You have to run a new cable.
Hmm.
The vampire taps you've used are dead because if you use the ones, they may not work again depending on the type.
Hmm.
So it's very difficult to like make adjustments. It's very difficult to add people to it, like scaling, as you said.
Hmm.
But it's also very difficult to like make adjustments and maybe move from one place to other stuff like that.
Yeah.
It's inflexible.
Yeah. Nice point. That's a really great point because that ties in also with what the guys were mentioning about Kent Kewa. But there's something else that's not been mentioned, and that is this half duplex. This network
Oh.
is a half duplex network. What does that mean when we say half duplex network?
Can only send or receive, but not both at the same time.
You said, can you explain that clearly, Mark?
It can only send data,
Yeah,
and it has to wait until the line is clear, and then before it can receive the data back or
exactly. So
packets.
basically, if this guy wants to send a communication, what happens is this guy has the thing he wants to send. This guy has what he wants to send. This guy has what he wants to send. The first thing they do is they listen on the line and they say, "Is there any communication going on? Because if there's any communication going on, I can't send anything." So if the line is clear, this guy goes, "Oh, the line is clear now, and now I can send my communication." And he goes and transfers his communication. Then after it transfers his communication, it can only go in one direction at one time. So it can only either be sending or receiving. So he sends, all these guys get the communication. So these guys, they are waiting. They're like, we're listening for the line to be silent. So when the line is silent, this guy goes, yeah, I can transfer my communication now. But then there's an issue that can occur where if this one sends at the same time and this one sends, then the frame gets messed up and then there's a collision and basically they all have to start transmitting again. So that's a big problem. Think about that in a modern network where if I want to send something, I have to basically hold on and make sure nobody in the office is sending anything. I mean, we can't just imagine a network like that nowadays, where if you want to send something, you have to hold on and say, hey, hold on, make sure nobody is sending anything in a 250 people office, then we can send something. So that was like the earlier network, but not to spend too much time with that. That was like the earlier network, the bus network. You only have a single line. Then after the bus, what did we move to? After the bus.
After birth, we move to ring topology.
To what?
Ring.
Ring.
Ring. Ring. Oh,
Yes.
so all those are like they are part of like the same generation where you have like the ring or the bus and that. So they actually like came out at a similar time. Mine was said mesh. Yeah, well, that's actually yeah. Yeah, so yeah, exactly. So all those just how the bus come together. Can you explain the question, Carlos?
Oh,
Well, is I'm not as familiar, obviously, but with the topologies, mesh, star, and ring,
Hmm?
basically just bus, but connected in a different way.
Yeah, yeah,
Okay.
yeah.
no, star is different. Star is what we use modern day now. Um, we have mesh is like a redundant, adding redundancy to star, but most times actually what we actually use nowadays is hybrid, but as in a mixture of it. But star is like you have is what do you call it? Hierarchical networking, or having like a king and then having squares, stuff like that. So you start from the top and then you spread out. That's what star is. But I guess maybe what you're asking for is it like switches or bridges?
Yeah,
Is that what you're asking for?
yeah. So talking about the evolution of like the networks. So the evolution from when we used to have, just the long code, the 10-base T network, where we had just one single cable on the network that's supplying everyone on the network. So after that, something else came to replace that.
Hubs.
Yeah,
I don't know.
yeah, exactly, which was our hubs.
Yeah.
So we had our hubs after that. So what's the difference between the hubs and the 10-base T and sorry, the 10-base T network? What's the difference between them?
Half duplex hub.
Yeah, but 10-base T is also half duplex. So
10
what's
B.
the difference
Oh,
between when the hubs came and when we just had a single cable on the network? What's the difference? So we go.
Can you give us a hint? Because the orbs basically, when we're talking about orbs, we're talking about half duplex, CSM, ACD,
Yep, good
which
one.
basically means our whatever we're sending, whatever signal we're sending on the network,
Mhm.
we gotta make sure that the signal we're sending is not gonna interrupt any other signal
Yep,
that's already active in the system.
yep,
But when we use the switch, basically that changes everything because the switch, everybody's sending signals on the switch, but the switch queuing all those signals, making sure that there's no collision because we only have uh, what we called um, everybody on their own collision domain.
yeah. I mean, what you're saying is absolutely right. But then, well, the question we're asking is, um, the one we first described, we described this 10-base 5 10-base T network. Um, when you have this network, it's basically like the things that you've described also, where we had a single collision domain, communication is half duplex. So is there any
Hmm.
difference between this and the hub? Is there any difference between them? Between this type of network that we used to have, this 10 base 5 network, and this when the hub came to replace it? What's the difference between them?
I guess it's all the same. It's one giant collision
Oh,
domain, right?
Yeah.
Yeah.
I guess the
The,
fact that it's just not in line, right? It's more logical ring, the hub itself.
yeah, the hub is a repeater basically.
What do you think? And I think Tahir hasn't spoken
I
that much
agree with
though.
them.
What?
I agree with them. I think they're right. Remy is it Mark and Carlos?
Yeah.
I think they're right. It's the same thing. The hub is almost the same thing as what you had before for the
Exactly.
vampire types.
Exactly. So they're basically the same thing. So logically speaking, they function similarly. Logically speaking, when you look at the hub, it functions logically as if what you had was inside this, you have a single cable where your computers are just connecting off the single cable. So that's just the way the hub operates. So logically speaking,
Hmm.
it has this nice casing on the outside, but logically speaking, it functions similarly. It's a layer one device, which means it doesn't understand anything above that. It only understands electronic signals, doesn't understand anything beyond that. It's you have duplex, you can't get a full duplex hub, so you can only be sending or receiving at the same time. That's the only thing that happens on that. Then you have only one collision domain where only one person can be communicating at a single time. So then you have the thing that Remy and Marwa have mentioned and Carlos also mentioned, which is which Marwa wonderfully put in the chat window, the collision the CSMACD, where you have a collision detection mechanism. So that was what came to replace the 10 base 5 network. We had this hub, but logically speaking, they function similarly. So after the hub, something else. Yeah, sorry, carry on, Kaya.
I have just a question. Like you have a hub network on the like on the earlier times we have a hub network, right?
Yeah,
Logically, it was same as a bus topology, right? Okay, like when a PC wants to communicate to another network
yeah,
on sorry, not on another network on the same network
yeah.
itself, another PC which is connected to a hub.
Mhm.
How does this communication happen exactly?
Does anyone want to answer the question that I here asked?
Okay, just repeat it again. Like you have two machines connected on this hub, right?
Yeah.
Okay.
So
Hub just
anyone wants to answer it? Remy, you want to help to answer Taya's question? So Taya is saying if we have, so let me repeat the question. What he's saying is if we have a hub and then we have two pieces connecting off this hub, how would
yeah.
they, if they want to communicate with one another, how will they communicate? Like what goes on with if they want to communicate with one another?
uh, this is basically simple because if computer one, let's say for example, want to communicate with computer two, in that case, it's only two computers on the line,
Mhm.
and it just basically like the cable was from computer one straight to computer two, and there won't be any interruption. It'll be listening to one line and sending to the other line, basically.
Yeah,
Um,
yeah,
if it was a switch, yeah, the communication will be completely different because the switch, all the communication will pass to the switch. But in that case, it's different. And let's say we added another computer on the line. In that case, you will have to listen to the line first in order to send information,
mhm,
and that will be the difference between that.
yeah. So basically
Anybody
speaking,
else?
Taher. So basically speaking, Taher, what Remy just said is that it's basically the same thing as what we described earlier. This guy wants to send something here. He still has to listen to this line for if anything is going on. So if nothing is going on, then it takes whatever communication he wants to send, packages it and sends it across to this line. And everyone that is connected to this device, to this hub, can hear that communication. Everyone can hear that communication. So the communication will come and get to this guy, and this guy receives it and all that. But if this guy wants to send something and this guy wants to send something also at the same time, they have to follow the same principle. They both have to listen to the line and make sure no one is transmitting. If this one transmits at the same time on the line and this one transmits at the exact same time on the line, there will be a collision. And the frames that they've both sent, or well, not frames, the electronic signals that they've both sent will be messed up. So the electronic signals will basically be discarded because it's messed up, and then they'll both have to hold on and make sure that nobody is communicating again. They will reset themselves to a random timer, and then they'll start communicating again. So it's basically, just think of this one as the 10-base 5 network in a box. It's exactly the same thing. It's not different. So let's move on from here. So after the whole hub came and all that, then something else came to replace the hub. What was that?
Talking about bridge?
Yeah, exactly. Good one, the bridge. So my question to you will be this, because you answered Remy. So what's the difference now between this bridge and the hub? You already said the hub and 10-base 5 network, they operate similarly. But what's the difference? What's the difference between the operations of this one and the operations of a hub?
If we already say that the hub is a layer 2 device, which means it's just transferring electrical signal.
A hub is a layer 2 device. How many people agree with that?
Yeah, so bridge is much more like more like a computer.
I asked a question. I said Remy said a hub is a layer 2 device. I said, how many people agree with Remy?
No, it's a physical layer.
I know that was a mistake. I just
definitely. Sorry about that.
I know it was.
Sorry about that. So, all right, I take that back. The hub is a layer 1 device. So when we get to a bridge, what we do with the bridge is that it's operated like a computer. Basically, we can store algorithm in there and telling the bridge, hey, this is how we want you to send signals. So if you receive a signal from that computer and you receive from computer 1 and you receive a signal from computer 2, make sure that you know where that signal is going. If you don't know where that signal is going, send a request, a broadcast to everybody who is on your line, and then if anybody responded from your signal, from your broadcast, then forward whatever message you received from computer 1 to that other computer on the line who responded with the MAC address, basically.
Yep. Nice. Okay. Nice.
So that's basically it's the algorithm that is inside that bridge that make it much better than the hub.
Yep, nice one. It's a nice one. Mark, what do you think? What's the difference between when the bridge came and what we had before in the hub? What's the difference?
I mean, the bridge has a little bit of intelligence to see whether.
Stop right there, Mark. That's a nice one. For mentioning that word, I'll give you 10 stars.
Sweet, I'm set for the day.
The key word there is this brought something that we never had before. It brought intelligence. Now we have a device that is intelligent. The hub is a non-intelligent device. It gets a signal, like Remy said earlier. It just basically repeats the signal. It doesn't understand what is going on. Gets a signal, repeats the signal. I have no clue what is going on. I don't know anything that's on my network. All I know is there's a signal that's coming in. I send it to everyone. I have no clue and I don't care. So it's a non-intelligent device. So the key point was the bridge brought intelligence to networking. It brought intelligence to the local area network. So carry on, Mark. You got 10 points now. 10 stars.
It has one input, one output, I believe.
Scott, if you want to be an Islam consultant, You have more chat immediately.
One input, one output, and I believe it'll inspect the packet to see if its destination should be on the other side of the network, the output. If not, then it doesn't send it out that way.
Yeah. Any other thing? Does anyone want to add any other thing? Hello,
I have a question.
Yeah, carry on, Tahir.
Okay, I have a question. Like how, like as a bridge, it has two collision domains, right?
It has what?
Like, do you have a bridge in which you connect two separate networks, right? Like on a hub.
Sorry,
like on a,
sorry, I didn't catch that clearly. Sorry.
Okay. I'll just repeat it again. On a hub, like
Yeah.
you have various machines which are connected together. Similarly, you have in a bridge. You have two separate hubs like that, which are connected together.
Yeah.
Hubs make bridges make it quite intelligent decisions based on the MAC addresses.
Yeah. Exactly.
Okay.
So here's the thing. The whole thing is before what we had with the whole hub. Let's bring up another whiteboard here. So what we had with the hub was we had this device where, like what you said, it's basically just one single line on it, and other lines coming off of that line where computers connect to. And what happens is we mentioned that if the computers want to communicate, only one computer can communicate at one time. So if a computer is connected here and a computer is connected here and a computer is connected there, and this is a hub, they can communicate at exactly the same time because this line it refers to something called a collision domain. It means only one. Well, it's not. It doesn't mean so. Only one. It means only one person can communicate at a time. All of them can communicate at the same time. But what we now have in the bridge was that even though all these computers are still connected, so we still have all these computers. Or let's just go. Let's make it simple. Let's just copy this. Let's make it smaller. Yeah. Okay. So let's say this is a bridge. This is not a hub. So yeah. Let's go bridge. So this is our bridge. So what happens is just this line by itself, this line, it's a separate collision domain, which means this one can communicate without affecting this one. This one can communicate without affecting this one. This one can communicate without affecting this one. Whereas in the situation before, all these devices are sharing this single backline. What now happens is it's sort of like this. It's sort of like this one goes here, this one goes here, this one goes here. Then there's now like another one like called like the hop link or something, the hop link that they all connect to, that they all share that one, but each one individually can communicate without affecting the other one. So they are no longer sharing this backline. They are no longer sharing this backline like in this case. So in this case, everyone has their own line. So that is the whole concept of collision domain. On the hub, they are all sharing the same backline. On the bridge, well, they are not. Each port, it's its own line. Yeah. So does anyone want to add anything else? What else? Any other difference between bridge and the hub?
I would add, if you can go back to that line, to that picture you were showing.
Yeah.
If you're looking at the line, even though we're saying that it's not sharing it, but it's actually an abstraction, because let's say every computer has a port.
Yeah.
And in that port, that computer can send message in that port, and for some reason, it's gonna go through a queuing process.
Good one.
The switch gonna say, okay, your message arrived here first.
Mm-hmm.
I'm doing that. I'm currently working for that computer number two.
Mm-hmm.
So let me finish computer number two, and I'll forward your message. It doesn't mean that once your message arrives and it shoots it right away, like
Okay.
you were talking about all those processes in the computer are working at once, but there's no such thing in computer that multiprocessing. Although he said multiprocessing, but those multiprocessing, they are not simultaneously doing the work at the same time. The CPU always queuing the first process and move on to the second process and the third process.
You know what? Let me for the point that you just made now. I think you should get 10 points also for that point.
Thank
because
you.
because that's a really important point. Because what Remy is saying is that all these, even though it's true that they have separate collision domain, each port is now a separate collision domain, they still share the same queue. So if this one is sending something at the same time, and this one is sending something, and this one is sending something, what happens is if they're going out, they have a queue that they all go to. And there are different methods that the bridge can use to decide how I process the queue. Does anyone know what the methods are? What the methods that the bridge uses to process the queue? It's three main methods. Anyone? Carlos, what do you think? There are three main methods. So a
Are you
method.
saying method?
Carry on. Sorry.
I'm sorry. Are you saying methods?
Yeah. So you have
I
a
don't understand.
bridge. So let's cancel this. I think this is becoming it's like messed. So you have a bridge. Let's try to
Priority maybe, or
well, you're close. So you have
Well,
first
I
in, first
remember like
out.
some terminology, but I don't know what it is. I mean, like multi-port bridging, about
so
that, like method.
you have this part here, and then right here you have. Sorry, let me get rid of this one. Let's use this one. So you have here, you have your buffer, right? So this is like your buffer. So this buffer is like a memory. So this guy is sending something, you know, he wants to send a communication. He sends the communication out. Um, let's have multiple of them. So hopefully this will make it clearer. So this one also wants to send something, and this one also wants to send something. So let's say this one sends something, sends the communication that it wants to send. If it were to be a hub, if they all send at the same time, there'll be a collision, and then they get dropped and they start again. But because each port is now a separate collision domain, it goes out and it goes into this buffer. And if this one sends at the same time, basically goes out and goes into this buffer also. And this one comes, it also goes out and goes into this buffer. And then these frames are processed in the buffer, usually using three mechanisms. What are those three mechanisms? Three mechanisms mainly. How the switch, how the
So I guess in the order it processes it,
yeah,
right?
yeah. So there are three main ones that it
Like it,
uses. Anyone?
um,
Carry on, Carlos.
first in, first out.
Hmm. You're going to QoS now. That is that's not what we're discussing. I know what you're talking about. You're close. But it's something similar to that, but it's got another name. Imran, what do you think? What are the ways that the bridge or the switch determines? Imran says fast switching. Well, you're close. Mark, what do you think?
I don't know.
Imran, look at Imran. Imran just gave a pointer right there. Good pointer from Imran. Check for 64 bits. That's one of the methods. Anyone know what it's called? It's called
Yeah,
something.
don't have any clue.
You're close. Mark, what do you think, Mark?
It's got to be something like that. I'm not sure exactly. I mean, it's either on the other side or it's not. So,
Powell, what do you
right?
think, Powell? Powell, what do you think? You may need to unmute yourself, Powell, because we may not hear you. Check source IP address. You're close. I hear you're close. It's basically three methods. I'm sure
Is it on
Maya one.
this?
I'm sure Maya one knows it. There are three of them. Number one is store and forward. Does anyone have any ideas now? Store and forward. Anyone?
You know that first in, first out, like I can't remember who said it,
Yeah.
was actually one of those algorithm that they used on the Switch, but I guess it wasn't that impressive for whoever was building the Switch, and
Yeah.
they just.
The first in, first out. That's for QoS.
Mhm.
That's for QoS. So this is just for processing the frames. So that's like QoS mechanisms that you're referring to in talking about first in, first out. But this one, anyone else have any idea like what it's called? Store and forward? Yeah, anyone? Okay, let me help again. Cut through.
Cut through, yeah.
Yeah. Which one? What's the last one?
It was a mixture, hybrid of both of them, store and forward and cut through.
Yeah. After
I
that, there's
don't
one
think,
last one, which is the
I
last
don't
one is the
remember.
one. Imran, you should know this because you described it for us. You said check for 64 bits. It's bytes, but check for 64 bytes. So what is it called? What's that method called? No,
Is that
store and
like
forward.
force?
What did you say, Mark?
I mean, just what these guys are typing in there. There's cut through. I don't know. I'm not.
Well, I'm just guessing here. Are we saying first 64 bits and then analyzing where it should go, the destination, or?
Yeah. So they are three. You're close, but there are three mainly. There's store and forward, there's cut through, and there's fragment free. So store and forward is this. So let's go. Let's try to take out these frames. So again, remember we're not talking about packets now. We're just talking about frames. So all these are frames. As far as the bridge or switch is concerned, they are frames. So this one comes in, it goes into the buffer. The buffer is like, oh, I'm going to transfer everything from this computer into this buffer. Everything, I'll store it first. After I store everything, I'll need to mute guys to avoid echo. Sorry. Um, then yep, to avoid echo. Um, let's see. Okay. Yeah, I'm not sure. Is that Remy? I'm not sure if that is the echo is coming from Remy. Yeah, I think it's coming from Remy.
What is it?
Okay. I think it's better now. No, there's an echo that's coming out. There's
Let
an
me
echo
mute
in the
myself
frame.
before that.
Yeah, nice. Okay. So we got this. So it stores the whole frame in this buffer, does error checking, so checks the frame if there are any errors in the frame. If there are errors in the frame, what do you think it's going to do with it? Yeah. What do you think it's going to do? Exactly. A nice one, Maya. It's going to drop it. So if there are errors, it's going to drop it. And then when it drops it, what does it do? Yeah. What does it do when it drops it, Maya? I'm not actually. If I think about that, I think my thought was that it regenerates it, but I'm not 100% accurate. My thought was that it's going to regenerate the frame. Yeah, I'm not too accurate on it, so you might be correct on that. But it's something that I'll need to like read the textbook about. But that's something to look up, like what it does if it drops a frame that has an error. So Maya, you want to help us with this and clarify that for us some more, so that we are clear a bit on this.
I'm not sure it does error correction at layer one. Depending on how the error is, if the error is something minor, because we do have what is called what's it called again? You have at the end of your frame or at the end of your packet, you have what is called
frame check sequence.
Frame check, yeah. So if it's, I've forgotten which one it is, but because depending on like if it's a switch or stuff, or like especially if it's a fast Ethernet switch or stuff like that, or bridge, it may or it may not. I'm not sure. I don't think it does. Most of them don't do error correction. If it does error correction, then what you're saying is that when he sees an error, he will try. That means he will have enough parity bits to be able to determine what the error is, and then correct that frame and correct the error so that he can do that. That's when it does error correction.
Yeah.
But if he's not doing error correction, just doing error checking,
yeah,
then all it does is check the parity bits and say, okay, you know what?
Yeah.
You know what? This information, this frame is wrong. I'll drop it. I expect that another frame will be sent because I know that the upper layers will resend anyway.
Yeah.
So
yeah. That's I think that's correct. Yeah. So if I remember, I think that's accurate. Okay. So basically, store and forward is it takes it, stores the whole frame, does error checking on it. If there's error, it drops it and basically waits for it to be resent. Then there's cut through. Cut through is a bit different. What cut through will do is it will only transfer just some part of the frame. It won't transfer all the frame. It will only transfer some part of the frame. It will transfer, I think it's 6 bytes of the frame. I think it's normally around 1500 bytes or so. So it's going to transfer 6 bytes of the frame. And the moment it transfers that 6 bytes, it starts sending immediately. So it's not going to wait and say, yeah, let me copy the whole frame, I'll store it, then I'm going to forward it. This one's going to say, the moment I receive the first 6 bytes, I start sending it instantly. Yeah. And then the last one, which is fragment free. So, but the issue with cut through now is that you can't necessarily like do real error checking because you've just copied 6 bytes. If there are errors, you're basically transmitting errors. Yeah, actually, they all check destination MAC address. Well, they check the source to be able to know what to put. But we'll get to your question, Taher. We'll get to your question. Exactly. Good point, Imran. What Imran is saying is that because there's no error checking in cut through, you may find out that many of your frames have errors because basically it's not storing them, checking them, and sending them. It's basically saying, I'm getting it, I'm sending it. As I'm receiving it, first 6 bytes, all I need to do is wait to receive first 6 bytes, and boom, I'm sending it out. Nice one. Nice. I mean, thanks very much, Mark. That's very useful. So Mark posted a link, so it'll be good for us. Nice one. Thanks very much for that link, Mark. So that's a link in the chat window posted by Mark. So this explains it in like more details about how the switch processes this stuff. So nice one. Okay, so the last one is fragment free. So fragment free is like the middle ground between the two of them. So fragment free says I'll transfer the first 64 bytes. So I'll transfer the first 64 bytes, and the thinking is this: is that if there's any error, I will detect it in the first 64 bytes. So it has a bit of both because it does error checking, and at the same time it doesn't wait to receive all the frame. So it receives the first 64 bytes, checks if there's any error. If there are no error, it starts transferring it immediately. Yeah, exactly. Nice point again, Imran. So what Imran is saying is that most errors, usually most, not all, but most errors occur in the first 64 bytes. So it's like, yeah, I'll check the first 64 bytes. If there are no errors, I assume there are no errors and I'll start sending it. Which one do you think is more used in modern switches these days? What do you think? Carlos, what do you think? Which one do you think is more used? Imran said fragment free. What, Carlos, what do you think?
Only because I read something about Cisco bringing back cut through for some reason.
Cut through, okay. Tahir says store and forward. So let's just take a poll here. If you agree with store and forward, say yes. That which one do you think Cisco switches use more nowadays? So if you agree with store and forward, say yes. Only one person said yes. Remy said yes. Well, I'll join you, Remy.
I think it's both together. When they check there is more error are coming, then it's back to store and switch, and when after some time it backs to to the fragment free cut through. Sorry, cut through.
Yeah, but newer switches. I'm talking about newer switches, not older switches. So Mark, you're right.
Newer switches.
Yeah.
Is it not Ceph? They are using Ceph from Cisco?
Well, we'll get to that one. But okay, what about cut through? Who thinks it's cut through that they use? We'll get to well, that's for another one.
Cut through like.
Who thinks it's okay?
We can use in voice over IPs telephony where their delay is more. You cannot bear the delay like the telephony or these kind of stuff because you need less latency.
Because
that's why you use.
Actually, I'm not sure, but I'm not 100% sure, but I'm almost certain that I read in a Cisco textbook that modern day switches use more of store and forwarding. I'm not sure if anyone has seen that, but I think almost certain that I read that in one of the Cisco textbooks because they said the processing power of modern day switches is so powerful these days that it doesn't actually make a difference in terms of performance when you're talking about store and forwarding or cut through anymore. Because the rate at which the buffer performs and the rate at which they process is actually really fast that it doesn't actually make that much difference. Or it doesn't actually make any difference. So I'm almost sure I read that in a Cisco textbook, but it's something that we need to clarify ourselves. But I think I'll go with Remy and say I think it is store and forward that is used more today. But we need to confirm that much more. Anyone read anything about that? That modern day switch is what they used more.
Oh well.
Yeah, go ahead.
Okay, so what I think is that it depends on what the switch is doing. That's why I asked if it was newer switches.
Yeah.
Like we do have like what he said, CIFS, and we have other stuff, other technologies that we use. I think in what was it? I've forgotten the name, whereby it just forwards frames quickly or forwards packets quickly without checking or something like that.
Yep,
in which case it doesn't do more store and forward. Cisco Express Forward, exactly. Yeah. So if that's Cisco Express Forwarding, won't really be doing more store and forward. It will be doing more like fragment free or cut through. So it depends on what you enable, the feature you enable on your switch. That's why I was like, I can't vote for any of them because you can make these newer switches do store forward, cut through, or fragment free.
Yep.
All the features are there. Yeah.
I was reading about.
I think.
Carry on, Iman. Sorry.
I think
you're right. Sorry, ma'am, but you're right. No. By default, it's store and forward, but I don't know. It depends on what you're running on switch.
I think I read in NetAcad, Cisco Academy, that actually they start with the store and forward, and then they switch cut through or fragment free. But when they find there are more errors coming, then they back switch to store and forward.
Correct, ma'am. You're right. That's what I was talking about. That the newer switches do a mix of it. With new frames, you use store and forward. When you get a new frame, okay, then you know that any other frame that matches this most likely is going the same direction anyway. Mm-hmm. So you just go immediately to cut through to make it faster. Mm-hmm. Then maybe when you start having errors and you're dropping, or the other side is saying they're dropping frames or stuff like that, then you revert back to store forward to make sure. So it's a mix in the newer ones now.
Yeah, actually, I think it's something that we need to research on to make sure that we're really sure about. I'm not 100% sure on this. So yeah, so that's basically like that particular side of it. So yeah, so now let's move on a step further. So now we've discussed and beaten to death the bridge. So it's a layer 2 device. Basically, a frame comes in, it tries to learn the MAC address and says, okay, this frame is coming in. What's the MAC address? What's the source MAC address? And so basically, it's like I like the way somebody put it, which is really like really simple. He said if you look through a door and you have three doors in front of you, and they ask you which door has an elephant behind it, and you look through the door, and in one of the doors you can see an elephant behind the door. In one of the other door you can see a donkey. In one of the other doors you can see a cow. But you look at one door, you can see an elephant behind it. And they say, which door has an elephant behind it? Of course, it's the door that you can see the elephant behind it. So it's the kind of way that the bridge operates. So the bridge goes, yeah, I've received a frame from this port. The frame says source MAC address AAA. That means AAA is is behind this port. So if I receive a frame with a source MAC from this port, that means that MAC is behind that port. So it's going to put it down in what is called its MAC address table and blah blah blah. And we're going to discuss that in more details in future hangouts and stuff. Okay, so that's for the bridge. So after the bridge, what happened? What's the next revolution in IT after the bridge? Anyone? After the bridge, what else? You need to unmute yourself.
After the bridge, I think it's switch came, huh?
Yeah, switch. Nice one. The switch. Nice one. Yeah, it's the switch. So since Mark gave us a very wonderful answer of the difference between the switch and the hub last time, so Mark, here's another chance to get 10 points. So now, what's the what's like different between the switch and the bridge? What's like the difference between them?
Switch and the bridge. Well, the switch will only send it out to the port that the packet is for the destination packet, whichever port that it's supposed to go to, instead of going out to all of them.
Can you explain what you just said now? Can you explain it more? You said the switch will just send it out to. Can you illustrate?
The switch will send the packet out only through one port to one computer instead of all of them at the same time, right?
Actually, what do you think? Does anyone want to respond to what Mark just said? Does anyone want to respond to that? Powell, what do you think? Or Pameni, you're even there. You've not heard your voice in a while. Pameni or Powell, what do you think? In regards to what Mark just said, do you think I should subtract 5 points from Mark, or do you think I should give him 5 points?
Come on, guys.
What do you think? Because I'm thinking we should probably subtract 5 points from Mark.
No.
Powell and Pameni, what do you think? We've not heard your voice. Taher, what do you think? Okay, so what Mark is saying exactly? I didn't really get what Mark said. So I think what Mark said is that the switch will send it to everyone. So basically, okay, Mark, let's go through this together. So
no, it won't. It won't send it to everybody.
So you have a switch here, you have a bridge here. Both of them have computers behind them. So you have computer A, computer B, computer A, computer B. Computer A has a communication to send to computer B. Computer A has a communication to send to computer B. If this is a bridge, and the bridge sends this out, what will happen?
So,
it'll go out to everybody, right?
Yeah, okay, good one. Thanks, nice one. Look at the chat window. Powell mentioned something important. So let's list it one after the other. So switch. So let's go. Let's try to make this. So let's go switch, and here we have a bridge. So what they'll do, yeah, bridge and switch. So computer A wants to send to computer B. Computer A wants to send to computer B. So it comes in here. Powell said something. Powell said the first thing that both of them will do is check what? Check MAC address table. So does everyone agree with Powell?
Mm-hmm.
Yep.
Yep. Anyone disagree?
He can have 5 of my points.
No problem, Mark.
I want to share them.
Your answer was so good the last time that there's no way we can take any point. That one word answer was really good. So the check MAC address table is the first thing that it does. And why? What's the reason why it checks the MAC address table?
So
he's a smart guy. He doesn't want to waste time.
I know. Get right to the point.
Imran said layer 2. Imran, can you expatiate more? Why does it check the MAC address table?
Because they check the MAC address because they make decision based on the MAC address.
Yep. Okay. So it says check MAC address table. Okay, let me put the question this way. What is it checking for in the MAC address table? What is it checking for in the MAC address table?
To map the IP layer 3 address?
Layer 2 address? Can you expatiate more? What is it checking? Which part of the layer 2 address? Because there are multiple layer 2 address in a frame.
They make decision based on the destination MAC address.
So let's make it a bit simpler again. Let's say this computer A has a MAC address of AAA, computer B has a MAC address of BBB. Computer A here has a MAC address of AAA, computer B here has a MAC address of BBB. So this one wants to send to computer B. So the first thing it's going to do is it's going to put together a frame. And the frame that it's going to put together, what will it look like? It will have different fields. It will have a field. What field will it have?
Source MAC address, destination MAC address.
Good one.
And then he has to map the port number with the MAC.
In this case, what would the source MAC address be?
AAA.
AAA, yeah. And what would the destination MAC address be?
BBB.
BBB, okay. So then it has destination MAC address BBB. Yeah, destination BBB. And then this is packaged and transferred. So let's make it smaller. Yeah, and then comes and boom, it goes into the switch. So Power said, first thing the switch is able. Okay, yeah, I need to check my MAC address table. What is it checking in the MAC address table? What is it checking?
He is checking a MAC address mapping to the port. On which port? Actually, he will map the source address with the port it comes from, and he make an entry.
Actually, if I look at this, I actually now begin to say what Powell said is not incorrect, but that is actually not step one. I'll actually say step one is that it checks the frame. And what is it checking in the frame? I'll say it checks the frame.
Isn't to see if it's even on that network or if it needs to forward.
Carry on. Powell brings an interesting point up. So Powell, you want to explain that? Come on, Powell, your mic should be working. Come on, we need your mic to be working. He said first check destination. So okay, what's the first thing that you would do? Will the first thing that you would do, will you check the source or will you check the destination? What's the first thing
is that because since the switch make decision based on the destination, and if that destination within the broadcast within the broadcast domain, the switch already know that he doesn't need to forward that message to the router. Instead, it's gonna send it to whatever other ports he needs to send it to. That's when he sent the broadcast within. He sent the broadcast to find out where that computer is.
Yeah. Okay.
Confusing.
Actually, because the first thing again, if I think about it again, I think I'm beginning to agree with Powell again. But
Mm-hmm.
the reason is that one of the things it has to do is it has to store the source MAC address of this computer in its MAC address table. That's the first thing it does before it checks destination. So I think I'm beginning to agree with Powell again to say it checks the MAC address table. And what it is checking in the MAC address table is it is checking, do I have the source MAC address in my MAC address table? Because it has to store it first before sending it to destination. So it looks and says, if this frame comes in, it looks and says, do I have AAA in my MAC address table? So that's why it checks the MAC address table. What do you think about that?
Plus,
Uh,
he also checks the does it is the entries in my table or not, or should I forward as a broadcast or unicast?
Yeah, it will do that after. But the first thing it does is I have to have a record of what just came in, because this one just came in now. So it's like, okay, this one just came in. First thing I need to do is check my MAC address. Do I have the source MAC address in the MAC address table? If yes, okay, I'll go ahead and check the destination and check, do I have that destination in my MAC address table? But it checks and says, do I have the source in my MAC address table? If no, it goes around and adds it to the MAC address table. And we go like this. Port 1, I lent MAC address AAA. Then after it does that, it goes to the destination and says, do I have the destination in my MAC address table? If yes, it's going to forward it. If no, it's going to do what? What will it do? It will send a broadcast, right? If it doesn't have it, it will just forward it to everyone apart from the one that it came from, right?
mhm.
So what's the first thing I'll do again? Check MAC address table. After check MAC address table, what will it do?
Wait, hold on.
Yeah.
Can I say something?
Carry on, Manoa, please.
I think yeah, I think really the way it does it, it doesn't really matter because it does it so fast. You don't know the difference.
Yeah,
But
it's true.
the thing is, if you look at the Ethernet frame,
Yeah.
the destination mark comes first before the source mark. So I believe it checks, especially if it's doing store forward or cut through or stuff like that. It checks for the destination MAC address, makes a decision on how it's going to handle the frame, and then as it's sending the frame out either through broadcast or through a port, it now registers that okay, I saw the source MAC from this port and adds that to the MAC address table entry or forwarding table entry, no matter how, whichever way you want to call it. So that's what I think it does. So I think you were right the first time that it actually checks the destination mark to see whether he actually knows where to send it.
Mm-hmm.
And then as he's sending it, he makes an entry in the forwarding table and makes an entry with the forwarding table on the source mark saying, oh, I saw this source mark address on this port. Oops, let me mute that.
Yeah.
Yeah,
carry on,
for some reason, I think I've read a long time ago, but I don't think it's so much concerned with the way you receive it, unless there's a port security in there. But because once you receive once the switch receive a transmitter from that port, it registered that MAC address because that's where it comes from. It registered it without asking question and forward the broadcast. If he has it, if he doesn't have that destination on his MAC address table, but if he check his MAC address table and saw that destination, then he send a unicast.
Yeah, you're
right. You're right.
Yeah.
Well, guys, if you can see what I'm presenting, you will see what I'm talking about.
Okay, yeah.
The actual, this is how it looks. So you see that you have preamble, which is what I call parity bits, is used to do the checks. Preamble actually is not used to do the check. It's used to make sure that you're transmitting. The CRC is what is used to make the checks.
Yeah.
The destination MAC address, it comes in first, so that's the first thing it's going to see. So it's going to make a decision based on that. Especially if it's doing, think about it, it's doing cut forward or cut through, or maybe store and forward. The first thing it's going to see is the destination mark. It will do a lookup on this mark table, and see, do I know where this destination mark is going? And then it now sends it. Then it now makes an entry based on the source mark that, okay, I saw this source mark on this port, or port 1 or AAA on port 1. It makes that. But it does those two processes so fast and so seamless. It's like it's doing them at the same time. So, but if you check the books, I think that's what it says too.
Yeah,
sorry,
nice
I'll
one.
stop. I'll
Nice
stop
one, guys.
presenting now.
Yeah, nice one, guys. Nice one. So I'm not like absolutely sure like as to that, like in terms of like the person. I'm not sure where I read it from. I'm not sure. Maybe it's like a textbook that I read it from where they were talking about it stores it in the MAC address table before making a forwarding decision. But I'm not too sure. But like you said, it does it so fast that it doesn't really matter. I think we'll probably learn about this one more when we start getting into like our CCNP switching and all that. But yeah, like I'm not sure. I think I read it somewhere. But the main thing is to know that he checks his MAC address table and to know that he checks both the source and the destination. He checks his destination to make the forwarding decision. It checks the source to find out is it already in the MAC address table. If not, I will add it. So the destination will determine how I'm going to forward this. Do I forward it outside a single port, or do I send it to every port apart from the one I received it from? That will be based on if it has a record of the destination in its MAC address table. So it's actually three processes that they call it, that the switch or the bridge performs. They call it learn. It learns MAC addresses. Yeah. Then there is forward. So it makes forwarding decisions based on destination MAC addresses. And then what's the last one?
Store.
Not store. Flood.
Flood.
Yeah. So if I
That
don't
will
know,
broadcast.
yeah, yeah, exactly. If I don't know where the destination mark, which port it is, I'll flood it. Again, I'll flood exactly. I'll flood it outside all ports, apart. Flood out all ports apart from the port that it came from. So that's what it does. So now we're moving close because we're moving close to our lap time because and we have just 6 minutes left to go. So we're still discussing like the major differences between the switch and the bridge. That was what led us to this. So if you were to explain to someone and say there are two differences between the switch and the bridge, what would you say? So let's go around. What would you say? Imran, if you were to explain to someone two differences between the bridge and the switch, what would you say to that person? And why? So you want to start from Imran. So we'll use that to end this session. Then we go to our labs. Yeah, you Imran, you. So what will you? So what will you?
I just know about that bridges, after the hub, they introduced bridges, and they were transparent layer to learn MAC addresses, and after that switches came, and that's I know about that, but I don't know much detail about the switches because
Yeah.
Actually, I really didn't.
Yeah, actually, Pamani is asking a question. Pamani says, when does it discard the frame? When destination is not found? No, when destination is not found in MAC address table, it doesn't discard the frame. So when destination is not found in MAC address table, it floods the frame. So the only time that I know that it discards the frame is if there's an error in the frame, or if you're doing something like MAC address filtering or something like that.
Oh, you're right. Yeah.
Yeah. So it
I
doesn't
think you're right.
actually, yeah, yeah, exactly. So that's
Yeah,
the
if an
answer to the
error.
question per many. So it doesn't actually discard the frame, except the frame is messed up in terms of after it does error checking, or maybe you're doing something like MAC address filtering or some other feature like that. Another. Okay, so Imran has given us his own answer. So Mark, what's your own answer? Two main differences between the bridge and the switch.
The bridge and the switch. The switch uses MAC address table.
What about the bridge? What does the bridge use?
The bridge separates two networks.
Think about it. Let me just throw this in. So you help you, Mark. The bridge and the switch, logically speaking, the same way we discussed and we said 10 base 5 and the hub, they function similarly, right? So the same way that we mentioned that the switch and the bridge, logically speaking, they function similarly. They perform similar functions. Not same function, but similar function. So the same way that the bridge operates is the same way or in a similar way that the switch operates. So it receives a frame, it learns the MAC address, it forwards it based on destination MAC address, and then it floods it if it doesn't have the destination MAC address in its MAC address table. So that's like so it's like similar. So having known that, what do you think? What else do you think? So if they are both similar in their functions or they both function similarly, so what do you think would be the differences between them? So if they both function similarly, why do we need the switch?
But the bridge wouldn't know because it doesn't have a table, does it?
It does. It does have a table. It actually has a table.
Oh.
It has, so the old MAC address table, the bridge also has its own MAC address table. So basically they function the same way. Anyone? So Maiwa, what do you think?
I think Paul is true. It's about hardware and software because the switches are hardware based. The decisions are switching inside is like hardware based, and the bridges are, I think, software. They do switching in software, and I think yeah.
Okay, so you said this one is software and this one is hardware. Can you explain that a bit more for us? So what does that mean? Because again, remember, IT people, we have to make things clear for ourselves. We try not to confuse ourselves because now people on the Hangout could be confused and could be thinking, now you've just confused me more, Himran. Now you're saying hardware and software, and I have absolutely no idea what that means. So what does it mean when you say this one is hardware based, this one is software based? What difference does it make?
Like you, if you remember that they say in the if you make a design a network, then you put distribution layer, and they say it's better you put multi-layer switches because it's switching inside, the internally in the hardware, so it's faster than a router.
Yeah.
So I picked that thing from the Paul wrote here. It's versus this hardware versus software. So I think he's right.
Yeah, it's absolutely right. I was just trying to make it clearer for other people. So what that means is they both function similarly, but the function is that if you have a bridge, the bridge performs all those learning, forwarding, flooding function. It performs them with a software. So what that really means is that it's slower. Yeah, because all the processes have to be done by the CPU. So it goes through the bridge, it goes through an application, it goes through a software, and exactly, yeah, good point, Powell. So the CPU is involved, your memory is involved. So all these things are like layers of delay, and the processing is much more slower. Whereas what happened is that when the switch came out, the switch had something called the ASIC, or because we're out of time now, because we have to move to our labs now, or what is called the application specific integrated circuit. And what that means is that all the processing doesn't go through the CPU or the memory. It goes through this ASIC here, which is way much faster in terms of like its processing, like you said. Yes, Powell. So, which is way much faster in terms of like its processing. So basically speaking, switches are faster versions of bridges. Really, really faster versions. Because this one process in software, whereas switches process in hardware. So yeah, yeah. So let's go to the next person. Pameni, what will be your own differences between the switch and the bridge? Apart from software and hardware, anything else that you want to add?
The bridges are transparent, so I think they can separate to network, but switches are not transparent. Yeah, but I think you can use as a transparent, like the VTP.
VTP, VLAN trunking protocol.
Yeah, that's like the servers and the client. Like if you don't want to take all the VLANs on one switch, then you make it like transparent, mode
See,
transparent.
we'll give
So
Imran. We'll come back to that. My what type something that is so good that we have to give him 20 points. Because we have to quickly give him 20 points for that one word answer. So we have software and hardware. The other main thing, as far as the way I see, the other main thing, which is like the main difference between them, is features. The features is the same reason why you buy the new iPhone 5 or the new, is because of the features. The same reason why you do the upgrade in your infrastructure. Why you say, okay, we've used, this old Intel Pentium machines. Now I want to move to these i5 processors. It's because of the features that come with them, the features that are available to you. So switches have way more features than bridges. Features. Can someone give me illustrations of the features that you have in switches? You have VLANs. You can do VLANs. You know?
Multiple VLANs.
Yeah, exactly. Multiple VLANs. What else can we do?
Trying to regain some of my points I lost.
Nice one.
I'm working really hard here.
Mention one more feature and you get 10 more points today. You'll be equal to Mayowa's points.
You can manage a switch.
Good one, Pameni. Port security, Pameni and Powell. Yeah. Come on, Mark. You can do it. Come on. Let me give you this one. I'll just give you that one and you complete the rest.
Oh.
Wait, I think
good ones.
Okay, I think you said you can, yeah. I think you said you can manage the switch.
Yes, I'm back in the green.
You got your 10 points now, yeah? So you're equal with my one. You got your 10 points. Nice
just in time to lose them for lab.
Nice one. Things like NetFlow. You got QoS. You got power over Ethernet. You got lots of features like that that you don't have on the bridge. And new features keep coming. You get things like stack switches where you can have, multiple switches that operate like a single logical switch. Like things like that. You get lots of wonderful features, that are available on the switches that you don't get on the bridges. And that's like one of the main things. So the two main things that you should remember is you have the hardware, the ASIC, and then you have features that are available to you. That's wonderful. So yeah, carry on. Any questions? Yeah, carry on.
I'm sorry, I never used bridges, but were there SSH or Telnet in bridges? Were they manageable?
Sincerely, I've never used bridges before. The only thing I know about bridges are things that I read in books. Has anyone ever used a bridge before? Anyone? I've not even seen one before, sincerely. Anyone ever used
Can I say something?
Yeah, carry on.
I've never used bridges either, but I think I've read extensively on some of those things, bridges. So basically, it depends from the time that switches hubs was about to outdate it and bridges was about to take over. It was mainly a company decision to save money, basically, because let's say you have about 10 hubs in your network
Mm-hmm.
and you're having problem with a bunch of communication issues on your network, then the best possible issue is to get a bridge in your network, so you divide your network into two collision domains instead of having a one single collision domain on your network. So it made it easy for company. By the way, Bridge did not have that many ports that switches currently have.
Yeah.
So
that's a good
make it possible for a company to just separate the network and separate the network in multiple collision domain.
Yep.
Plus getting all those, but it didn't have that many features like we said before.
Yep. Nice one. Nice one, guys. Nice one. So we got page 23 to 61 today. So if you look in the chat window, page 23 to page 61. So that's the lab we're doing today. So it's basically on switching also. So it's basically on managing switch operations. So if you look in the chat window, you see the link to a PDF, and then you see the labs that we're doing today, which is labs 2.51, 2.52, 2.53. And that's from basically from pages 23 to pages 61, or sorry, to page 61. And yeah, and that's the lab that I'll be doing today. So if you want to share, so what we just do, if you want to share your screen, you can share your screen, guys. And you just use Packet Tracer. I'll be using Packet Tracer. You can use Packet Tracer for this lab. You can, Packet Tracer, GNS3, whichever one you want to use, feel free to use it. For switching, I use Packet Tracer for now. But yeah, so that's basically the ones I'll be doing today. So if you want to share your screen, feel free to share your screen. I will just walk through this lab together. That'll be good. So you ready, guys?
Oh, are you guys doing something else now?
Yeah, we're doing the labs now.
Oh,
so
I gotta move out.
Yeah, no problem.
I was gonna be here until that time, so I guess I'll talk to you next time, guys.
No problem, man. Nice hanging out with you. Nice hanging out with you.
Okay.
Yeah, see you next time.
Okay.
Yeah.
So which lab? What page is it on?
So that's page 23 to page 61.
Oh, the lab is on 23, 61.
Yeah. So we just walk through the lab today.
Let me see. 23. So what book are you using? The Cisco Academy?
Yeah, exactly. The Cisco Academy one.
Oh, okay.
All
900 pages of it or something.
you have the hard copy, do you?
Yeah. It's a pretty big book. I mean, it's no joke. This is some serious stuff.
Yeah.
I went through the whole thing this week. I couldn't even tell you what was on day one.
Yeah, I'm not sure. Yeah, I'm not sure. I think I prefer like the Cisco, the NetAcad, like 01, right by 5 minutes. No problem, man. I prefer the NetAcad process because basically they emphasize on understanding the stuff than just doing quick trainings and stuff.
Yeah. I have all the
yeah, carry on.
The labs. I have them all on a flash drive here, and they actually grade you as you go through.
Yeah.
It's pretty cool with the packet tracer.
Yeah. Nice one, man. So I tell you, like, I know these are like pretty basic for like most of us here. If you want to like work on another lab while we newbies are working on this one, feel free to work on another lab.
23. Yeah, it's good practice still more.
Yeah, it is, yeah. Even though they're basic, but it's still good practice. The other thing I find out is that sometimes even in doing like basic stuff, there are some really, really little stuff that we miss sometimes. Like, just some really, really little stuff that you just go back and when you learn it and all that stuff. It happened to me when I did like my Microsoft training. I mean, typically we just think, yeah, I know Active Directory and I know that stuff. Then you start, when you do like the course and they just share like some really little stuff, you're like, I didn't know that.
Yeah, exactly. Yeah, because those boot camps, they go way too fast. they pass over a lot of the stuff, and it's, you don't understand. Like yesterday we did NAT.
Yeah.
And
when did you start that? You already started NAT.
Yeah, I know. We just started on Monday, and Friday we're doing that. And I'm like, I was so lost. I had no idea. I just didn't understand like the concepts behind using the the reverse subnet and all that. I was like, why? Why are we using this? It was just too quick. So.